Hello, my name's Cummings, and today we'll be talking about the Aquaponics Hydrotron. So aquaponics is very similar to hydroponics, where we're growing plants without soil. But the difference between aquaponics and hydroponics is hydroponics uses nutrients from fossil fuels, and aquaponics uses nutrients that come from fish waste. So the inputs are very simple. It's fish food and then maybe some iron or something like that to make the lettuce a little bit darker green, since the fish food is made for fish and not really for nutrients for plants. And then the plants that grow in our system is lettuce. We filter all the solids out and it's just the fish water, and that's really high in nitrogen. And that's really good for vegetative growth. But in order to grow fruiting plants, we need more nutrients. And we do that outside when we have a gravel root zone. And that way the fish species is in the gravel root zone, because the gravel root zone is the filter for the fish tank below. Now we have enough nutrients to grow fruiting plants like tomatoes and cucumbers and peppers and stuff like that. So we grow tilapia because it's a very forgiving fish. It can tolerate high concentrations of ammonia and nitrite. It can handle fast changes in pH and temperature. In Stephenville, we can have tilapia because they can't overwinter. If they could overwinter, they might be an exotic fish that displaces a Texas native fish, but that's not going to happen in Stephenville. So we take the fish solid waste and we compost it by adding sugar and lots of air, and we use it as a potted plant fertilizer. So we don't really have a discharge to the environment, because we can bottle up our fish waste and put it on potted plants, and some of the larger particles of fish waste that we can filter out, we feed to freshwater prawn. So we're growing freshwater prawn and tilapia as animal protein sources, and we're growing lettuce mainly as our vegetable component. So aquaponics uses fish to fertilize plants and plants to filter the fish water in a recirculating loop, with the aid of some microorganisms that convert the ammonia from fish to nitrates for plants. So students like how sustainable aquaponics is. You can live in the city where there's bands and Wi-Fi and grow fresh food that doesn't have to travel very far. So that lowers the carbon footprint. You're buying locally, and the food is super healthy and fresh, so you're going to throw less away. In a warehouse, you can grow lettuce vertically and have many heads on 1 square foot. Some of the warehouses that you support brick and mortar buildings might be not occupied, and then that would be a great place to introduce an aquaponics system. Aquaponics is super healthy because there's a real reduced use of pesticides. Organic people can use soaps and oils to control insect pests, but oils don't mix with water and soap don't mix with water. So pest control in aquaponics is exclusion. You don't let them in the building. We use sticky cards, and we remove sick plants, and we use biological controls. So the type of plants that you grow in aquaponics depends on the type of system you have. When you're in the fish water, you want to grow leafy plants like lettuce. And when you have a gravel root zone where the fish waste deposits, you can grow fruiting plants like tomatoes and cucumbers and peppers. But if you want to grow a root crop, we do that in a decoupled container. It's called a wicking bed. And we put the fish waste in the bottom, and the roots of the plants go down to the fish waste, and that way the part that you're eating was never submerged in an animal waste. So the aquaponics lab, or the hydrotron, is right next to the meat lab at the Tarleton Agricultural Center, or the farm. aquaponics class is offered in the spring. It's WSES 3309. And in this class, we learn all about the filtration in the fish and the plants, but we also learn how to cook the food. We catch and fillet tilapia, and we harvest our fruits and plants, and we create a salad, and students learn how to cook the food with simple ingredients in a skillet that they can have. So what we're wanting to do is increase the limit of the class to 50 students and offer 2 lab sections. So in labs, students help fabricate aquaponics systems like a stacked IBC tank. We build towers for lettuce, and then we grow lettuce that we can sell through the purple tractor or through Big O's. I couldn't operate the aquaponics facility without students. I need students to help clean the deep water cultures graphs, and I need students to help inventory the fish so I know how many fish I have and what size there are. It's not the number of fish I have, it's the pounds of fish I have. So I was approached by the owners of Big O's. They wanted to build an aquaponics hydroponic system in their restaurant. And I was skeptical at first, but when I found out they had an east-facing window, I thought, well, let's give this a chance. So we built a system that has 6 10-foot pipes, and we put about 12 lettuce plants in each tube. And they use aquaponics water from the hydrotron, and they also supplement with some hydroponics lettuce fertilizer as well. So I bring them cucumbers and lettuce that I finished off and help them grow the lettuce that they started. In the future, I would like the aquaponics class to make more of the IBC systems that we can sell through the purple tractor. I'm interested in learning from students and teaching students how to cook and fillet fish. Fish is a very responsible animal protein, and I want students to learn how to eat more fish, and I want them to learn how to prepare a healthy meal from raw ingredients.